Hello friends, welcome back to our channel. Today we will see one more algorithm in our machine learning, that is a KNN regression. So in our previous session we have discussed about many algorithms related to the classification. So classification means based upon the input the prediction will be the classification or the categorization. So but coming to the regression, so here the prediction will be a numerical value rather than the classification. So we will see the regression. So KNN regression. So here we have seen the KNN classification algorithm. So where we are supposed to find the closest nearer points and then the classification will be predicted. But here the regression means prediction of numerical value. The prediction will be a numerical value. For example, predicting the percentage of a student based upon number of hours the person studied. And coming to the classification, so based upon the number of hours studied by the student, it will predict the category whether the person fail or pass. But regression means it will give the numerical value. So prediction of temperatures from the old data. Okay, so prediction of house price based upon the area. So this particular prediction means, regression means predicting the numerical value, and the complete algorithm is similar to our KNN classification, right? So we'll see the first one. Consider some data set. So training the data set should be done, training and testing. After completion of this thing, provide input, any input, and find distance. So usually it will be Euclidean distance between new data point to all instances of training data. So we have to find the complete distances. Then select k value. So what is a k value? So how many neighbors we need to select? Number of neighbors we need to select, and then here it comes. Now, so in our classification, it will find the voting and it will consider the majority. But here it will, after selecting the number of neighbors, then it will calculate average of all k neighbors. And this calculated average is prediction for given input. Whatever the input we have given, for that input this particular average is a prediction. So hope you understood. It's a very simple. So here also we are not implementing from the scratch. So we are supposed to use the existing one, that is a k neighbors regressor, the class k neighbors regressor. So that is that class will be used for implementing this KNN regression. So after completion of this theory part, we'll move on to the system and I'll show you the implementation. So let us take an example so that you can understand clearly. Example. So number of hours studied. So I am taking this one as an example here, but while implementation we'll consider the previous data set, that means house price prediction. right? So number of studies, hours studied, number of hours studied, and here instead of taking the classification we need to take percentage. We'll consider percentage. Let it be some name of a student. Name of a student. So A, student A studied some 3 hours, so got some 40%. B with 4 hours, 45%. C with 6 hours, it is about 60%. D with 7 hours with 65%. E with 10 of 90%. So let us consider this one. Now F, the student F studied 8 hours, studied some 8 hours. So what will be that particular person's percentage? So this is the question mark. How we have to do? So we can consider the k value, that means how many neighbors we need to collect. So let us take it as 3. So always we are supposed to take the odd numbers, okay, odd numbers, and it should not be 1, because if you consider only 1, so the complete prediction will be depending upon only one data set, I mean only one data. So let us take it as a 3. Now we have to find out the distance here first. So distance from a new data point to remaining all. So 8 minus 3 it is a 5, 8 minus 4 it is a 4, 8 minus 6 it is a 2, 8 minus 7 it is 1, and 8 minus 10 it will be 2. So what we need to consider? 3. What are the 3 nearest neighbors? So 3 nearest neighbors are C, D and E. So these are the neighbors. If we consider k as 4, we have to consider this one also. Okay. As of now, only these 3 are. So what we have to do? We need to calculate average for all these 3. So 60 plus 65 plus 90 divided by 3. So how much? 125 and 215 by 3, which is nothing but 71.6. So this will be the predicted percentage. 71.6 is a prediction. If a person studies some 8 hours, the predicted percentage will be 71.6. If the person studies 7 hours, the prediction is 65, and if a person studies 8 hours, the prediction is 71.6. So the student may get around 71.6 percentage. So this is how we need to implement this KNN regression. Regression means numerical value, not the categorization. It is prediction of numerical value. So it will consider n neighbors, that means a k neighbors, k nearest neighbors. So here is the 3 parts. K means the number of neighbors we need to consider, n means nearest, and n is neighbors. So 3 nearest neighbors, we need to consider the 3 nearest neighbors, and then we need to calculate the average. Now we'll move on to the system and we'll find the implementation, the Python implementation of KNN regression. So we are using the predefined class called K neighbors regressor, right? So let's move on to the system and hope you understand. You will be understanding much better, right? Yes.
Hello friends. So just now we have seen the complete theoretical part of KNN regression, and now we'll see the implementation part. So for the implementation, I have taken some data sets, which is a house prediction, which we have seen in our previous session with a small modification. So here I have added the price because in our previous algorithms, that's a classification. So if you give the area, it will classify the group. Okay. And in today's session, there is a KNN regression. Instead of giving the group, it will predict the price itself. Okay. So I have taken one more column called a price, and I have given some price to each one, right? Now, in the implementation, see, first one is a pandas because we have to read the data set and we need to create a data frame. So in order to access the data in tabular forms, that too in data frames, we required the pandas package. So I have imported the pandas and I'm giving some alias name called PD so that Wherever we want to use a pandas, we can use PD. And the next one, we are using KNN regression. So there is a one direct class called K neighbors regressor. So we are not implementing this particular algorithm from the scratch. So we are making use of existing one. So the existing one name is a K neighbor regressor. This is a class. So which is available in a module of neighbors, which is available in sklearn. So I have written from sklearn.neighbors. That means in sklearn package, in neighbors module, we are using K neighbors regressor class. Now, the first step, we need to read the data set, and this data set is in form of XLS. So I have given a read Excel, pd.read Excel, so that the complete data of Excel sheet will be moved to the data. So I have printed the same. Next, we need to take the input and output. So here we need to give the area so that it will predict the price. So input will be the area and output will be the price. So in the data frame, I am giving the X value as an area and Y value as a price. Next, this is a KNN regression model. So here we need to take the neighbors. So I am taking 3 as a neighbors. So we need to select the 3 nearest neighbors, and we need to average the prices of those 3 neighbors to predict the value. So I have taken here k is equal to 3 because k should not be 1, because if it is 1, the complete prediction will be depending only upon only one particular data. So mainly use any odd numbers. So I have taken 3. So next, model. So as I said that this is a class, I am creating one object. So model object. Model object is equal to k neighbors regressor, and here I am taking the k value. So how many neighbors? N underscore neighbors as a parameter. So for that parameter, we are taking some k value. Here I have initialized k value as 3. And now we need to train the model. So in the train the model, we need to give model.fit x comma y, and then we need to take the area. So is equal to float. That means we are taking the input from this particular area and we are converting, okay, converting the input into a data frame. So we are, whatever the input we are taking, that we are converting into a data frame. And finally we are predicting the price. So in order to predict the price, we are having a function called a predict. So model dot predict new house. Model dot predict new house. So what happens, whenever we have given this area, first it will find the distance from that particular from the given distance to given value to the all other instances of the data frame, right? From that we need to consider three nearest neighbors. So we need to add all the things, all the values of all the 3, so that we'll be getting the result here. Okay, that will happen for the predict. And here predict function is called with the help of model, which is a object of already available k neighbor regressor. So I'll execute and I'll show you. So I'm executing here. First a data frame will be displayed here, and then it will prompt for area. We need to give the area. So let it be our area, consider it as 1,000. So we need to consider the distance from that point to all other points. So sorry, absolute of 1,000 minus this particular area, and we need to find out the distance from all other instances of dataset. See, so among this we need to consider 3, because in our program we have considered 3, k as 3. So here we have considered k as 3. So here we are giving what is the value here we have taken. So that is 1,000. Okay, here also we'll give 1,000 here. So enter house area in square feet, that is 1,000. So it will automatically predicted house price in lakhs is 86.67. So now let us check. So what is the nearest neighbors? So these 3 are the nearest neighbors. These three are the nearest neighbors. So what we need to do, we need to take the average of all these prices, three prices. So average, I'm taking the average. So this one to this one. So these three are the neighbors, right? So average D11. So it is 86.66. So what we got? 86.67. Because here we have rounded that to 0. I mean two decimals. Two decimals. So if it is 0, then it will be getting 0 decimals. Here I have the 2, so we are getting 2 decimals. This is a round function, right? So hope you understood. So classification means, so based upon the nearest neighbors, it will predict the category, whether it is a small, medium or large, based upon the area. The input is same. But in the regression, okay, it's not a classification, it's a regression. So in this regression, so every step is same, but instead of predicting, it will take an average of prices of nearest three neighbors in the program, and it will predict the result. So the three nearest neighbors are H10, H11, H12. So in among all these things, the prices will be averaged, and we got the result as 86.667. So here the result is the value. That means the result is a numerical but not the classification, right? So this is a very simple KNN regression algorithm. So hope you understood this one. And if you are having any queries regarding this one, feel free to post your doubts in the comment section. Definitely I'll try to clarify all your doubts. If you really enjoyed the session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.